The next structure is the cuboid. How does a cuboid look? This is a cuboid. So how different is it from a cube? Well, here we can have the length, breadth and the height to be different. They need not be same. They can be same, but they need not be. So we have 6 faces here too. 1, 2, 3, 4, 5 and 6. So pretty much everything that we have around, like a phone to a box, they're generally cuboid. We hardly get cube wala structure. It's mainly cuboid. So as a diagram, how do you put it across? So in your exam, you just need to draw something like this. This is your cuboid. So here the length, breadth and the height, they can be different. So we can clearly see they are of not the same length. So this is how you represent it along with their respective units. I forgot to mention this in cube, but yes, we need to write the units as well. Now let's begin with the total surface area. So as usual, we'll have a look at a video to help us with this. So what we're looking at is a cuboid. As you can see, here the structure is different. Here it's bigger. Here it's smaller. And here it's even more smaller. Here bigger, smaller. So you can see there are 3 different areas of different unit, that is of different measurement. So that would be your length. That would be your breadth. And that would be your height. Generally, this is how it's considered. It need not fix the length, breadth and height to be of this manner. It can be anyhow. And the height. So if you open up a cuboid, how does it look? Well, that's what we're going to see. Right, it's quite simple. You guys can also do it at home. Try it. If you're learning it for the first time, I would request you guys to do this. So we have this particular structure. So how many faces are there? Clearly there will be 6. So that is your total surface area of the cuboid. So I'm trying to draw the boundary so that it's visual. I mean, it's kind of easy to look at. So that is your cuboid. Now, so the first thing is, let's remove the extra part. So this is the extra bit. It's meant for connecting or joining things. So this we can ignore. So remaining we have 1, 2, 3, 4, 5 and 6. 6 faces. So if we consider this as a top, this would be your bottom. Top and bottom. This is important to recognize because when we talk of lateral surface area, we need to be clear with what we are dealing with. Okay. Now, how do you find the total surface area? Well, we have the top and the bottom. Let's start with that. The top and the bottom would be, okay, I kind of lost the, yeah, the top would be something like this and the bottom also will look the same, is it not? So this is not your bottom. Yeah, this is your bottom. So it has length and breadth. So L into B is the area of the top and the bottom. There are 2 of them, is it not? The top and the bottom, there are 2 of them. Length into breadth, there are 2 of it. So total surface area is equal to 2 times of L into B. Plus, we have the sides. First and the third one indicates the side. Side is basically this. This is the side. This is basically your height into breadth. But there are 2 of them. Height into breadth. As you can see, it's indicated by your first and the third one. Height into length is the remaining one. So this would be your height into length. Let me show it over here. This is your height into length. So this would be plus 2 times of height into length. So this is how you can remember the formula. You need not further reduce this and all that. That's of no use. Try to keep it this way. It's very convenient to remember it this way because in different scenarios you won't be using this exact formula. You will be taking an abstract of it, a part of it. Okay, so please understand how we get each of this formula, and then you will be able to apply it in a better manner. Now the next thing is your lateral surface area. So lateral surface area is to do with the sides. The top and the bottom has to be ignored, and we have 1, 2, 3 and 4. So these are the faces that we need to consider. So basically the top, just a second, I'm not able to select this. The top and the bottom. Yeah, if we remove this is your lateral surface area. Okay, so if I remove the top and the bottom, we have the lateral surface area. So basically that would be what? That would be your length into height, and what else? Let me have a look over here. So length into height and height into breadth. So basically the height term has to be there. And remember there are two of it. 2 into length into height plus 2 times of height into breadth. Height is common in both of them. So that's how you can remember. If not, according to the question, you can just directly write the answer. Not an issue. Okay, let's come back to this. So now we are looking at finding the volume. Right? So for that, we'll make use of a plane which is of same length and breadth. So that is basically this. So we're going to make use of this. So what should we do? Copy. Okay, not that. Copy, paste. So this I have to do it a few times. Right? If I keep doing this, what will we get? Let's have a look. So it's a bit bigger actually, bigger than what we require. But yes, even this is a cube. So this structure also will add up to be a cube. Let me kind of remove this and get it down. Oh, I stuck removed. Okay, that won't help. Okay, again it's moving. Anyways, this is also a cube, not cube, sorry, cuboid. Can you see that? This is a cuboid. If I keep arranging in this manner, right, in a better manner actually, this structure would be a cuboid. So what is that we're looking at? First thing that we begin with is right, a plane. Is it not? We got a plane. So this is of length L and this is of length B, breadth, that is L and B. So area of this is L into B. So if I stack it up to a height of h, so that would be adding L and B h number of times. So what will you get? So we know that volume can be obtained by area into the length. So area is L into B and it is stacked to a height of h, length of the third side, that is. So what is the volume? L into B into h. Again, this idea of getting the volume will help you in the future videos. That's why I'm teaching in this manner. I know you guys find this topic very easy, the cube and the cuboid, but still the methodology in which we learn is what is new to you guys. So I would appreciate if you guys are a bit patient and learn in this manner. Now let's analyze. So let's look at the total surface area, and the formula is 2 times of LB plus 2 times of LH plus 2 times of HL. So in each of this dimensionally, right, whichever are getting multiplied, the variables there are LB, LH, BH. What are the power? 1 and 1. 1 plus 1 is how much? 2. Again I repeat, the variables which are getting multiplied, the highest power is 2. Here 2, the highest power is 2. Here 2, the highest power is 2. Again, I'm talking about the variables and their respective power. So the combined power is 2. So again, remember, anything to do with area is of 2 dimension, and thus the powers will be 2. Yes, we can add any number of set of variables whose power is 2, but their power will not add up. Okay, how will the powers add up? As per the formula, a to the power of n into a to the power of m. It's only the terms which are multiplied in which we can add the powers. Right. Next is volume. Volume is LBH. Here the powers are 1, 1 and 1. So this will add up to 3, is it not? 1 plus 1 plus 1 is 3. So volumes are always 3-dimensional, right? So this is how we can analyze. You got it? So this is the power of understanding this way. Again, all of this will come in handy in time. So let me not try to justify it over here. As and when we use it, you will get to understand. And when you get stuck somewhere with any kind of formula, all this will help. So you can take that, I can assure you of that. So again, pause and please do write it, even though you guys know it, just write it. It'll hardly take 5 minutes.